This is part two of our 12.3 lesson. In part one, we just looked at a couple of probability problems, a real brief intro to probability, and basically found that probability, the way we're talking about it, is essentially when you take. Let me give you an example. When you take, let's say, the probability of rolling a 3 on a regular die is, well, how many total possible outcomes are there? Well, there's 6, and the one we're talking about, there's only one way to get that, so 1 out of 6 is my answer. It's a fraction. It's 100% is really the top potential probability, but it's a prediction. Will it happen or not? If you're sure it's going to happen, like what's the chance I'm going to roll, but something between 1 and 6. Well, that's 6 out of 6, or 1. 1 is the highest probability, and 0 would be the lowest probability. What's the chance that I roll a 7 or greater with one die? 0 out of 6, 0. So all probabilities are between 0, 0%, and 1, 100%. What are the chances of it happening? Somewhere between 0 and 100%. But that's review. This lesson I want to get into just a little bit more about theoretical and experimental probabilities. And that sounds like, oh, it's something else you need to memorize, but really you can just use it based on the words that you already know. And let's just imagine a study. Imagine a study where they flip a coin 100 times. And in theory, the probability of getting heads is what? And then in the actual experiment, will you get that many heads? Like, if you flip a coin 100 times, will you get exactly the amount of heads that you should in theory? Well, probably not. So your experimental probability is what you got for that experiment, shown by a given experiment. For example, if 53 heads, then 53% heads. In theory, of course, the theoretical probability, based on possible outcomes, and in this case, it's 50%. 2 possible outcomes, 1 way of getting heads, 1 out of 2. So that's theoretical and experimental probability. And that's all, that's really all you need to know about it. All right, one other thing I want to talk about with probability before we move on. So that is here. I'm going to clear the... It's like, no, you're not. You're not going to clear anything. I'm going to clear off the ink, and I'm going to move over this problem, move onto the screen this problem. And yeah, it's from the teacher's edition, so you have the answer in there with you. But the problem is, in exercise 37 and 38, use the following information. You and a friend are playing a word game, sounds like Scrabble, that involves lettered tiles. The distribution of letters is shown at the right. At the start of the game, you choose 7 letters. I guess it could be bananagrams also. Okay, they show you over in this table over here how many A's there are, how many B's there are, how many C's. What is the probability that you will choose 3 vowels and 4 consonants? Count Y as a vowel. There, I'm covering up the answer so we don't look at that. Cover up this answer down here too. And then what is the probability that you will choose the letters A, B, C, D, E, F, and G in order? Now I found this one to be much easier than this one. So now is a good time for you to pause this and try it on your own a little bit, and then we'll talk a little bit more about it. All right, now you're hopefully back after having paused it. So one thing that you probably did for this, I'm going to talk about A. Like I said, B was less interesting to me. B was easier. But A, you're like, well, what are the chances of getting a vowel, on your first draw? So to figure that out, you have to figure out how many ways are there of getting a vowel, how many possible outcomes there are. And so you have to add and count. So first you have to add all these numbers together to find out how many possible outcomes there are. There's 100 tiles. Then you have to add all the vowels together. So A is 9, E is 12, I is 9, O is 8, U is 4, and Y is 2. Add that all together and you get vowels are 44. And since the total letters are 100 and there's 2 blanks, consonants must be, that means the vowels plus consonants must be 98, so consonants must be 54. So maybe to explain how I figured the rest of this out then, I should talk to you about how I got B. The probability that you choose the letters A, B, C, D, E, and F and G in order. Now again, you might want to pause if you want to try that yourself. But what are the chances of drawing A on your first try? 9 out of 100. What's the chance of getting B on your second try? Well, it'll be 2 out of 99. Chances of getting C on the third try, 2 out of 98. D on the fourth try, and again, I'm getting the numerators from over here. 4 out of 90, and then the number of tiles is just going down by 1 each time. And if I continue this multiplication problem, I'll get this answer down here. So that problem, and again, I said if I continue the multiplication problem, this just tells me the chances of getting A, B, C, and D. I'd have to continue on with E, F, G, and H. No, just E, F, and G for my next, to finish the problem. So with that framework, it makes sense that maybe if I wanted to try to find the chances of getting 3 vowels and 4 consonants, I would think, well, 44 over 100 times 43 over 99, and so on. And so that's exactly what I did try, and I got this. So your job then, and I'm going to end the video here and we'll talk about it in class, is to figure out why that's not correct.